Good morning, everyone. I'm Jyoti, a lecturer in Chemical Engineering Department in State Government Polytechnic, Bengaluru. In the previous sessions, we are all been discussing of the subject called the instrumentation process control of the fifth semester of Diploma Chemical Engineering of the process variables, temperature, pressure, and measuring instruments, which is of Unit 1. In continuation of the Unit 1, today we will learn one of the temperature measuring instrument, that is a resistance thermometer. So in the previous class we have learned the temperature measuring instrument, that is called the thermocouple. So what is thermocouple? The thermocouple is nothing but the two dissimilar metal wires are being joined in order to form two different junctions. One is the measuring junction, the other one is the reference junction. Are you recalling the previous class? So what is thermocouple? The thermocouple consists of two metal wires, two dissimilar metal wires which are being joined together to form a closed circuit. So the one end is being called the measuring junction, the other end which is joined is called the reference junction. So what is the principle of working of thermocouple? The difference in temperature between the two junctions is directly proportional to the measure of the temperature, which is in turn indicated when the two lead wires are again connected to the galvanometer or the voltmeter, which is in turn calibrated in terms of the temperature. So thermocouple is capable of measuring very high temperatures. There are many different types of thermocouples. You can recall the type A, type K, type S, type N. So these are being classified as different types of thermocouple based on the two dissimilar metal wires construction. So that may be platinum and platinum rhodium, copper and constantum, platinum rhodium with certain percentage, or the platinum rhodium with a certain percentage. So based on the materials of construction, the thermocouples are being classified into different types of thermocouples, that is type A, type K, type B, type S. So these are the various types of thermocouple. These are all we have learned in the last class of the topic called the thermocouple, which is also one of the type of the temperature measuring instrument. Today, so this is today also we are learning the temperature measuring instrument, that is electrical resistance thermometer. So the contents in today I am going to cover is what is resistance thermometer, what is the principle of working of resistance thermometer, the construction and working of resistance thermometer, the advantages and disadvantages, and after learning all these topics, we will solve some of the MCQs based on these topics. So the resistance thermometer is one of the electrical type of resistance thermometer. So it is also been called as resistance temperature detectors, or RTDs. Before going in detail the principle and working and construction working of the resistance temperature thermometers or the resistance temperature detectors, you have to have a knowledge of certain the technical terms. So like what is resistance, what is current, what is ohmic value. What is resistance, by the way? So the resistance is what is resistance? It is an electrical resistance. If you speak in terms of electrical point of view, the electrical resistance of an object is a measure of its opposition to the flow of electric current. So the normal term you can understand, resist. You resist somebody coming to you. So you are stopping somebody to coming to you. So similar way, the resistance is what? The resistance of an object. If you want to define, the resistance of an object is a measure of its opposition to the flow of the electric current. It mainly resists or it opposes the flow of the current in any particular circuit. So that's why the resistance are being used in the circuits, electrical circuits. So I'll repeat once again, what is resistance? The resistance is the electrical resistance of an object is a measure of its opposition to the flow of electric current. So mathematically it can be denoted as R is equal to V divided by I, where V is the voltage and I is the flow of current. So like how exactly the RTDs look like, or what exactly the RTDs, resistant temperature detectors, consists of? It consists of length of a fine wire wrapped around a ceramic or the glass core, but the constructions are also, but other construction also used. The mainly it is the long length of the fine wire which is being wrapped around the ceramic or the glass material, and also it is a pure material. The pure material may be the typically platinum, nickel and the copper. And the material has an accurate resistance temperature relationship which is used to provide indication of the temperature. Whatever in the RTD we will use the resistance wire, it has got the accurate resistance temperature relationship which is used to provide the indication of the temperature. So these resistance thermometer have high accuracy of the measurement, and also they have a repeatability. They can measure the many number of repeated values, and the values which are given by the resistance thermometer are also close to each other. That is called the repeatability. Repeatability, we have learned this the term and the meaning of this term in the first session of the unit 1. In the static characteristics. So accuracy is nothing but ability of the instrument to give the true value of the output. So these RTDs, because of its high accuracy and repeatability, they are replacing the thermocouples in industrial application below 600 degrees centigrade. In order to measure the temperature below 600 degrees centigrade, the thermocouples are being replaced by resistance temperature detectors. Are you understanding? So the RTDs are what? These are the fine wrapped fine wire which is being wrapped around the ceramic or the glass core. There are other constructions are also available. Typically the fine wire is made up of the platinum, nickel or copper. Let us learn what is the principle behind working of the resistance temperature thermometer, resistance RTDs, resistant temperature detectors. So as we know that the resistance of a certain metals changes with the change in temperature, right? This is the basic property of a resistance of a certain metals. So the resistance of a certain metal changes with the change in the temperature. So with the increase in the temperature, the electrical resistance of certain metals also increase, which is directly proportional to rise of temperature. So by measuring the electrical resistance of a wire, of known wire and known and calibrated material, the temperature of the wire can be determined. So there is a direct relationship between the electrical resistance and the thermometer. So wherever in any closed circuit, if you measure the electrical resistance, it is directly gives in terms of the temperature. So that is the basic principle. They are related to each other. With the increase in the temperature, the resistance of certain metals also increases. So that is, it is directly proportional to rise of temperature. So that is the principle. So before going to the construction, the working of the resistance temperature detectors, let us look into the diagrams. So you can, this is detecting sensing element, sensing resistance element X, LR1 and LR2 are the lead wires which are being connected to the V-stone bridge, and A, B, C are the resistances which is being in turn connected to the galvanometer. So how exactly the resistance thermometer looks like? It consists of the platinum wire and it is enclosed in a porcelain insulator, and again it is being enclosed in a metal sheath. So the two ends of this platinum wire, which are the resistance wire, are being connected to two lead wires, which in turn connected to the V-stone bridge. Are you getting? This is how the diagram looks like, the resistance temperature detectors. You can see the resistance. This is how you can visualize by looking. By looking at this diagram, you cannot visualize how exactly the resistance thermometer looks like. But looking at this diagram, you will get an idea how exactly the RTDs look like. You can see this is a metal sheet enclosed. Inside this you have a platinum wire and the sheath and the glass head. And the end of this platinum wire have been connected to the two lead wires. So these lead wires in turn connected to the V-stone bridge arrangement. The solid view of resistance thermometer. This is how it looks like. So let us understand the working and the construction of the resistance temperature detectors. So as we already know that resistance elements are long spiral-like wires enclosed in a metal sheath. Spiral-like wires enclosed in a metal sheath. These are the resistance wires enclosed in a metal sheath. The resistance element is surrounded by the porcelain insulator, which prevents the short circuit between the wire and the metal sheath. Can you see from the diagram? Resistance wire. This resistance wire is enclosed in a metal sheath and provided with the insulator. So the insulator helps in short circuiting between the metal sheath and the resistance wire, which is of platinum. The two leads are attached to each side of the platinum wire. At the top, you already seen that the top of that resistance thermometer, the extension of the resistance wires are called the lead wires. When this instrument is placed in a liquid or gas medium whose temperature is to be measured, the sheath, the outer the coverage, that is the metal sheath, quickly reaches the temperature of the medium. So this change in the temperature, as it quickly achieves the temperature of the medium which has to be measured, the change in temperature causes a platinum inside sheath to heat or cool, resulting in the proportional change in the wire's resistance. This change in the resistance can be directly calibrated to indicate the temperature. Are you getting? There is a direct relationship between the resistance and the temperature. We already learned in the principle of working of resistance thermometer detector. So how exactly it works? When this instrument is placed in the medium whose temperature has to be measured, the resistance wire quickly acquires the temperature of the medium, and as it quickly acquires the temperature of the medium, it heats up. So the increase in temperature causes the proportional change in the resistance. By measuring the change in the resistance, we can indirectly measure the temperature of the particular medium. Okay. And the bridge consists of the sensing element X having the high temperature coefficient. You can see sensing element. This is the sensing element which has high thermal coefficient. So these are the resistances. ABC are the resistances and the galvanometer. When there is no current flow, these resistances are balanced and the galvanometer does not show any deflection. So when this resistance element is dipped in a measuring liquid whose temperature has to be measured, there is a change in the resistance in the inside the circuit. So there is an unbalance in the V-stone bridge. So when there is an unbalance in the V-stone bridge, the galvanometer shows the deflection. The deflection which is calibrated in terms of temperature. That is the working of resistance thermometer. See, can you see the resistance? As the resistance X changes, the Wheatstone bridge becomes unbalanced, and thus the galvanometer will give the deflection, which can be calibrated to give a suitable temperature scale. Are you understanding the working? The bridge consists of the resistance X. You would have observed in the diagram. So this is the resistance element X, which are connected with the lead wires R1 and R2 to the Wheatstone bridge, having the resistances A, B, C, and which are connected to the galvanometer circuit. So when the Wheatstone bridge is balanced, there is no deflection in the galvanometer. So when it is unbalanced, there is a deflection in the galvanometer. When it becomes an unbalance, when there is an increase in the resistance with an increase in the temperature. So when this resistance sensing element X is being dipped into the measuring liquid whose temperature has to be measured, there is an unbalance in the Wheatstone bridge circuit. This unbalanced shows there is a flow of current, which is there is a change in the resistance. So that is calibrated in terms of change in temperature. So we will, after learning, what are the advantages of the resistance temperature detectors? So it is advantageous because of its high accuracy measurement, and it is also small and compact inside, and it gives a very fast response and good reproducibility, and wide temperature range from -200 to 650 degrees centigrade. That's why it is being it is being used in industries to replace the thermocouples. Disadvantages: high cost, need for bridge circuit power supply. The bridge circuit is very necessary in order to give a power supply, and there is a vibration in the system. The larger bulb size than the thermocouple. So the applications is used to measure the engine temperature and oil level sensors, intake air temperature sensors. So it is also used in communications and instrumentation for sensing over the temperature of amplifiers, transistor gains and stabilizers, etc. And it is also used in power electronics and the computer, consumer electronics, food handling and processing, industrial electronics, medical electronics, military aerospace, in order to measure the temperature with high accurate values. So these applications and advantages and disadvantages you have to understand thoroughly. You have to have a knowledge of the advantages, disadvantages and the applications of resistant temperature detectors. I hope you have understood this session of resistance thermometer detector. So after understanding, let us solve some MCQs, multiple choice question based on this topic in this session. First question is, resistance of certain metals changes with a change in dash. So you have to in order to answer this, you have to have a knowledge of the principle of working of resistance thermometer. So whether the answer is pressure, temperature, viscosity, none of these. Resistance of certain metals changes with change in answer is temperature, change in temperature. So there is a linear relationship between the resistance and the temperature. So any change in the resistance, there is a change in the temperature. This is the principle of working of resistance temperature detector, RTDs. Electrical resistance of certain metals increase in dash proportional to the rise of temperature, whether it is inversely, directly or constant or none of these. What? The electrical resistance of certain metals increase in dash proportional to the rise of temperature. It is directly proportional to the rise of temperature. Third question, eye accuracy in measurement is done by using dash thermometers. Mercury thermometers, thermocouple, resistance thermometer, pyrometers. Are you recalling the session to answer this question? It's very easy. The answer is resistance thermometer. The temperature range of resistance thermometer is what? Whether it is minus 200 to 800, minus 200 to 1000, minus 200 to 700, minus 100 to 200. As I keep on telling that you have to have a thorough understanding of the various operating temperature ranges of various thermometers. Answer is minus 200 to 800. So define resistance. As I explained in the beginning of this session itself, without understanding the resistance of what is resistance, you cannot understand the working principle of resistance temperature detectors. What is resistance then? Resistance is, so in electronics and electromagnetism, the resistance is being defined as, it is a measure of what? The measure of opposition to the flow of electric current. Measure of its opposition to the flow of electric current. So similarly, how do we denote the mathematically the resistance? The mathematical representation of resistance is R is equal to V by Y, V by I. V is nothing but voltage, I is the flow of current. R is equal to I by V, R is equal to V into V star I, R is equal to I plus V. What is the correct answer? V by I. That is the ratio of voltage to the flow of current. That is the resistance. So to measure the engine temperature, and oil level sensor, intake air temperature sensor, dash are being used. Whether it is manometers, the pressure thermometers, or the resistance thermometers, or the thermocouples. The answer is resistance thermometer. The RTD wire is a pure material, typically what? Whether it is a platinum, nickel or copper, iron, nickel or chromium, silver and platinum, none of these. I've told in the beginning of this session, the RTD wires is of pure material, platinum, nickel and copper. So the answer is the first one. The platinum, nickel or copper. So RTDs are slowly replacing their thermocouples in industrial application below 1 degree centigrade. 500, 200, 100, 600. It is below 600 degree centigrade. So resistance thermometers are, whether it is an expansion thermometers or radiation sensors or the electrical temperature sensors or the field systems. It cannot be expansion because expansion thermometers are liquid filled thermometers and the mercury thermometers and the bimetallic thermometers. It cannot be radiation sensors. There is no any radiations coming out from any object here. And it cannot be field system also. There is nothing in the, as you can see in the diagram, from the diagram, there is no filling liquid inside the system or the electrical resistance thermometer. So obviously the answer is electrical temperature sensors. So it is the electrical temperature sensors. Before concluding, you have to understand the balancing of the V-stone bridge. So when the resistance of a bridge are equal, then the balancing of the V-stone bridge takes place. That is, we call it as ohmic values are equal. What are ohmic values? So ohmic value of a material or the components are nothing but that obeys the Ohm's law, which means they produce the same value of further resistance regardless of the value of V or I which is applied, and whether the applied voltage or the current is DC or AC. So all the resistances show the same value irrespective of the application of voltage or the current or DC or AC. So that is the ohmic values of the resistances are equal. That is the meaning of the ohmic resistance of the ohmic resistances of the based on which are equal. So this term you will come across the study material which has been given regarding this session. So here you have to remember the quick recap of this session. You have to remember what is resistance, what is current, and what is the principle of working of thermocouples. You have to remember, you have to practice the diagram of the electrical resistance thermometer, and also the construction and the working part, and some of the advantages, application and disadvantages of using this electrical resistance thermometer. I hope, thank you. I hope you all benefited by listening to this session. For more understanding, the study materials of this session is also available. And also you can refer the links which have been given here, and also the books, the instrumentation and the process control by A.P. Kulkarni, and the process and control and instrumentation by R.P. Vyas, the 7th edition. Thank you.